Okay, good morning, everyone. How did your homework go? Please put any questions you have on chat and so we can proceed. I give you a minute or so to gather your thought. Go ahead. So I'm giving you a minute to put your questions until everybody join. I think I put on the quiz to how many decimal places you want to round the answers. Okay, so it's written down on the quiz itself. Any other questions? Okay, so there is one problem I left you with last time, and I will gonna go over it, and then we proceed to the following section. So if my memory is correct, which is usually it is, I left you with the problem about the Eiffel Tower. I would like to know what you guys have done with it, and then I move on to section 8.3. So I look at the problem and
I don't even know.
okay, sorry, I have to mute. Okay, so my problem was, or the problem was, to measure the height of the Eiffel Tower, a person stands away from the base and measures the angle of elevation to the top of the tower to be 60. Moving to 110 feet closer, the angle of elevation to the top of the tower is 70. The question is, how tall is the Eiffel Tower? So let us remember how the picture was. So that's number 35 in your book. Okay. And the picture was like this. So you have the Eiffel Tower here. That's the Eiffel Tower. Okay, right there. We don't know what the height of it is. So what we do is we go a little bit far away and we measure the angle. And I realize that the angle is 60 degrees. Then we move a little bit to 110 feet. And the angle is measured again. And now the angle is 70 degrees. Of course, the angle gets larger. Okay, how can we use those two information to figure out h? So the question is, we need to find the height, we need to find h using the given. All right, I expect ideas. And please, all of you, put your camera on. Thanks for those who have it on. Please, the rest, do it. Okay, so how shall I find h? Idea, anybody did the problem? Anyone would like to take the lead? So I need this side h. And this is the info I have. So how can I get h? You have to find the other angle first. Which one, Aaron? Aaron, which angle? All of them. Okay. You tell me what all of them are. What's this angle here? So first you told me find the angle. What's this angle here? This is 70. This angle here should be, you know, the sum of the angle here is 180. So this angle will have to be 110. So we're working with the angle. Very good. What about this angle here? That's 60. That's 110. So this will put me at 170. So this angle is going to be, I would like answers on chat. I'm copying what you guys write. Done. Okay, so now we have lots of angle. And then what would you guys like me to do? Remember, my goal at the end is to find the angle, the height h. So how shall I get to h using the info you are giving me so far? So the angle, very good. We found the angle. So what do you want me to do? Law of sine to find what? So I'm going to give names here just to help us. A, B, C, and D. So you want to use the law of sine to find what? BD and AD. So the student want to find BD and AD. Now, why do you want me to find both? Do we need both? Okay, so we're going to use the law of sine to find BD. Okay, and then we're going to ask, remember my goal is H. So the student are after this side here. From here to here. I guess my pencil is not, my red one is not working anymore. Okay, so we want to find BD. So how shall I use the law of sine? Okay, to use the law of sine, I have to look for an angle and the side opposite. If I have an angle and the side opposite, I am in a good shape. So sine of 10 over 210. Every time I have an angle, the side opposite to it, the law of sine is adequate because I can set it up. Now I want BD, so I need the sine of 60 over BD. I'm just going to call it BD because that's exactly what we need. Very good. So now we cross multiply and I will get BD. Okay, actually, let me call it C because it will be easier for us if I call it C. So it means the sine of 10 over 210 is the sine of 60 over C. So C is much easier for us to work. So now we cross multiply because I have two ratio. That's the easiest way. Cross multiply. Okay, and this will give me my C. So now I divide by the sine. I divide, so this will give me 210 times the sine of 60 over the sine of 10. And this will give me the sine C, which is BD, equal. Okay, so anybody did the math? Anybody did the math? Okay, 1047.32. Okay, anybody got anything like Rebecca? Anybody else? So it's 210, 1047. All right, so the same. Very good. Okay, so very good. So now we found C, but my goal is H. How do you want me to find H? All of you. So the student found C. This is 1000, let us say 1047.32. Now, how can I find H? So we're doing it two steps because I need H, but I really don't have much to work with. How do I, it's easier to figure out the angle D than use law of sine for H. Okay, I'm having the issue. Do we need law of sine for H? All of you. Do we need to use law of sine for H? Look at the picture very carefully. So now I am inside this triangle. Right, no. What type of triangle this is now? What type of triangle this is? To find H, I have a right triangle. Do I need at this stage law of sine? No, not really. I don't need that anymore. I just have to use the properties of the right triangle. So now let us find H. What can I say? I have this angle, 70. I have C. So how can I bring H to the picture? What do you want me to use? I need H. I have C. And I have this angle. What shall I use to be able to find H? I give you a minute. Watch very carefully. I don't want the law of sine. I don't want a law of cosine. So somebody is writing something. So this is a right triangle. So I can say to find h, I say, all right, I have 70. I need the side opposite to it, and I have the hypotenuse. So now, since I am in a right triangle, I'm going to say the following. The sine of 70. So I went back to my picture, is equal to h over 1047.32. So at this stage, I don't really need law of sine. I don't really need the law of cosine. I am into a right triangle. I use the basics. So whenever I am in a triangle, I use basics. So now I need the h. So I multiply both sides by 1047. So I will get h equal, so this is my unknown right here. This is my unknown. So I'm going to multiply, this is my unknown. So I'm going to multiply by this. So I'll get h equal 1047.32 times the sine of 70. And then finally, I just plug in those into a calculator and I evaluate the height. So everybody is giving me 984.16. I definitely trust them. Okay, so that's really how we can. So it's a two steps process. I want h, but I don't have any info to get h. I have 60, but I don't have the side from here to here. So the idea, okay, find this one in between, and then we proceed. Okay, very good. So today we're going to move to, we're done with what happened with a non-right triangle. So what we saw in 8182, if you are working with a right triangle, how do we find the sides if we have angles and side? And we did that for the non-right triangle. Now we're going to move to another idea, basically totally different. So it's section 8.3 in the book. Polar coordinate. I wish they put this section at the end of the book, but they plugged it in here. All right, let's see the idea of polar coordinate. Honestly, it's not related to 8.1, 8.2. I don't know why the book put it in here, but it's a very important idea. Okay, what's the idea of polar coordinate? Okay. It's the idea of locating point in the plane. So let's see. If I want to locate point in the plane, so if I take you, I have a point here, and I want to tell you where this point is. What I usually give you is the x and the y coordinate. So if I tell you this point is, the x coordinate is 2, the y coordinate is 3, I can locate the point in the plane. So to locate the point, I can give you its coordinate 2 and 3. 2, 3 are called the Cartesian coordinate. 2, 3 are called, so the x and y, we give them a name, and they are called Cartesian coordinate, or sometimes rectangular coordinate. Okay, so the rectangular coordinate or Cartesian coordinate, it's a way to locate a point in the plane. So if I tell you the point -1, 3, or whatever, -1, 4, I'm locating this point. I'm telling you, okay, you go -1 in this direction, and then 4 in this direction. And that's really my point. Okay, so that's what Cartesian coordinate. Now, there is another way to locate a point in the plane that doesn't involve the x and the y. So how else can I locate a point in the plane? Before I introduce it in a very abstract way, suppose I tell you, sketch the point. Sketch the point P. Suppose I tell you that, such that I give you the following information. OP form an angle, let us say 50 degrees with the positive x-axis. Sorry, with the positive x-axis. So I give you the following two information. I tell you OP form an angle of 50, and then I tell you the following. OP is let us say 2 units away, sorry, point P is 2 units away from the origin. Okay, so I'm telling to sketch a point such that OP form an angle 50 degrees positive x-axis with the positive x-axis, and the point P is 2 units away from 0. Can you sketch this point? Is it easy or hard? What do you think? Can we all sketch this point? Can we locate the point in the plane that satisfies both conditions? Okay. The point have to form an angle of 50 with the positive x-axis. If I start with the positive x-axis, I need to move 50 degrees. And P is 2 units away from 0. It means if this is 0, from here to here, 2 units. So my point P, if I give you those two information, you can actually sketch the point. So this point here is 50 degrees and is 2 units away. 2 and 50 will be given a name, and they will be called the polar coordinate of the point P. So it's another way to locate point in the plane. Instead of giving you the x and y, I will be giving you two different information. I will tell you how far is the point from the origin and the angle that OP forms the positive x-axis. So now 250, before I will be called the polar coordinate. So it's a way of locating point in the plane. Polar coordinate. So let us define polar coordinate in a more formal way. But that's the idea. It's the idea, okay, I want to tell you where the point is. I can tell you the x and y, but there is another way, which is very important. I tell you the angle, and I tell you how far it is from origin. What we get is called the polar coordinate. So now let us define polar coordinate in a more formal way. So polar coordinate. I'm going to repeat myself, but with more symbolism. So polar coordinate. So again, it's a matter of locating point. That's really what the whole thing is about. Okay, suppose that P be a point in the plane. Point in the plane. A point. Okay, so this is my point. It could be anywhere in the plane. So it could be here, here, here. It doesn't really matter. So let me put it here. Okay, that's my point. And let theta be the angle between the positive x-axis. So it's important what theta is, the positive x-axis and OP. That's my theta. Okay. And let r be the distance. Let r be the distance from origin to the point P. So r is, this is r. Then r theta. R theta are called the polar coordinate of the point P. So I can give you a point. So if you have a point in the plane and I want to locate it, instead of giving you the Cartesian, the x and y, I will give you what we will be calling the polar. It means I will tell you the angle that form the positive x-axis, and I give you the distance. So let us sketch few points in polar coordinates. So the first problem is very simple example. Sketch the following point given in polar coordinates. So draw the point. So I'll have to draw them. Draw the point with the given polar coordinate. So we have to be careful, polar coordinate. Okay, all right. So I'm going to draw several points. So what I'm going to give you now are polar coordinate. So suppose I give you 3, 60. I'm going to put degrees because to mention. So when I tell you 360, right now, the 3 is the R and the 60 is the angle. Okay, so we have to be very careful what's inside those. So the picture is here. It means the point formed an angle of 60, so we go 60 degrees, and it's 3 units away. And so this is my 60, and from here to here, that's 3 units. So that's 360, and I'm gonna put in polar to tell you that that's the coordinate that we are working with. So I'm gonna take another one. Suppose I tell you draw the following point. 3, whatever, and pi. Where is this point gonna be quickly? Okay, now back to you. If I wanna draw it, where is this point going to be? Either write on chat or speak.
Wouldn't it be along the x-axis?
Right, where on the x-axis?
180 degrees.
Yeah, so what do you want me to do? Where should I go?
Put a point.
Start from here?
You're going to put a point on the left side.
Exactly. How far from the origin?
3.
3 units. So that's my pi. From here to here, it's 3. That's the unit. So be very clear. So this point is not, so this point will be 3 pi, and I'm going to put in polar, so you know exactly this is the polar coordinate. It means 3 represent how far we are, and pi represent the angle that it formed the positive x-axis. Do not confuse this with Cartesian. In Cartesian coordinate, in Cartesian, it means rectangle, the regular old coordinate, this is nothing more than minus 30. So we have to be careful which coordinate we're working with. But in polar, it's 3 pi. So whenever I have something like that, at least in this section, I have to tell you which coordinate system I am working with, all right? Okay, let's do another point along the same line. And remember, when I don't put anything here, it means the unit is radian. If I put something, it means the unit is degrees. So suppose I put 4 minus pi over 6. So definitely I am working in a degree here. So again, we have to locate the point. That's the angle, and that's how far we are from the origin. If the angle is minus pi over 6, it means I have to go pi over 6 this way. And then I have to go 4 units away from the origin. So the distance from here to here, that's to 4. And this is minus pi over 6. Remember, all those are in polar. All right, I will do one more, and this time I want you to tell me. So 4, 2. Okay, I give you a minute to interact with it. And this is in polar. This is in polar. It means this is r, the radius, the distance, and this is the angle. So in which quadrant do you think the point is going to be? Remember, this is in polar, so do not confuse it with Cartesian. This is in polar. I give you a minute to tell me where this point should be and which quadrant. Okay, I need more answers. I need more answers. Okay, everybody. Why quadrant 1? Why quadrant 1?
You said that if you didn't put any signs to the left or right of it, you're assuming radians, right?
Exactly. 2 radian is almost how much?
So it should be in quadrant 2, not quadrant 1.
Right. 2 radian is almost how much in degree. Now, last time I gave you an idea because I wanted to understand a little bit the radian. 1 radian. Anybody remembers how much is in degree? Almost. It's 180. A radian is 180.
It's approximately 60 degrees.
Over pi. which is almost 57 degrees. You have to have a picture of how much is a radian. Otherwise, you won't be able to draw this point. So 1 radian is 180 over pi degree. It means almost 57 degrees. Okay, and I want you almost to memorize this number because to be able to function with radian. So when I put 2 radian, it means I'm talking about like 100, almost a little bit less than 120 degrees. So this will put me in which quadrant? This will put me in the second quadrant. Is that very clear? Those are in polar. So now I have 2 radian. So now here, from here to here is 2 radian. Because I did not put a unit, not I don't. I mean, nobody puts the unit. When it's radian, they don't put the unit. They put the unit to degree. And then I am 4 units away. So this is my 4. So it's confusing a little bit, but I want it to be like this. So this is 4 and this is 2 radian. So 2 radian, it's almost 114 degrees. That's now to help you a little bit. And this is my point. So this is 4, 2 in polar, because in Cartesian is definitely different. In Cartesian, the x coordinate is negative, the y coordinate is positive. So in Cartesian, it's a very different story. But this point is given in polar. So it's another way of locating points in the plane that's not the regular xy coordinate. Okay. So I'll give one more and then we proceed. So let me again come up with something. Suppose I give you, I'm going to work with radian a little bit, and 5, 6. Okay, I'm choosing those on purpose. My question to you now, which quadrant the point will fall into? And this is in polar. So remember, it means this is the r and this is the theta. So we're going to draw this point. This is in radian. Which quadrant? Now we're doing better. Everybody's telling me it's in quadrant 4. Absolutely correct. So now, right now, 6 radian. It's almost, sorry. I mean, we know around a circle that is 2 pi. 2 pi is 6.28 radian. So 6 radian is really very close to 2 pi, not quite. Right, so it's almost, somebody is telling me almost 342. And now we 42 degrees, and I think she's absolutely right. So now I have to go all around like this, almost up to here. That's 6 radian. It means 342 degrees. And I need to go 5 units away. So it means this is my R, that's 5 units away. So this means that this point is 5, 6, but this is in polar. So those are the polar coordinates. The first is how far we are. The second is the angle. Okay, so that's the idea of polar coordinate. Why we use them will be clear, hopefully by the end of this lecture or next time. Why we use them, we will talk about that a little bit later. Now, every point in the plane now have 2 sets of coordinates. It has an x and y coordinate, and it has an r theta coordinate. And the question now is, if I know r and theta, can I find x and y? And if I know x and y, how can I find r and theta? You have to go back and forth between those 2 coordinate systems. So conversions between polar and Cartesian coordinate. Okay. We will do the easy one first. So the idea here is the following. Let us say I take a point in the plane. That's the idea. A point. Every point now has 2 sets of coordinates. It has xy, that's the Cartesian. So it means this is my x, this is my y, and point has 2 coordinates, another set of coordinates, the r theta, which are the polar. And now the question is, so polar, it means this is my theta, and this is my r. Okay, so that's really the picture for us now. So the question is, suppose we know, so now from polar to Cartesian. What do I mean by that? Okay, it means suppose we know r theta. So here we suppose we know r theta. And the question is, how can we find the x and the y? So I know r, I know theta. How do we find x and y?
You can take the sine and cosine of angle theta.
Yes, and let's be very precise. Tell me how.
You're taking cosine for x and sine for y.
No, you're half correct. Who can fix? This is correct if I am on the unit circle.
Oh, I apologize. Sine is
Right? But now I have radius r. How will this affect the picture? So I'm going to show it to you in this right triangle because that's how it will be helpful for you to actually memorize it. But what I'm going to say here work even if theta is in the second, third quadrant. Let me tell you, look at this right triangle. What's the cosine of theta in this right triangle? Remember, from here to here, I have r. So it's going to be the cosine.
it's going to be x coordinate over your r.
It's x over my r. Crucial, because the height now is not the unit circle, it's a circle of radius r. So this will give me that my x is going to be equal to what? All of you. What's going to be my x?
R cosine theta.
R cosine theta. So it's not cosine theta because it's not the unit circle. It's going to be r cosine theta. That's going to be my x. And this is because we have a circle of radius r. Now what's going to be the sine? The sine is the opposite. This is my y over my hypotenuse, which is the r. So this will give me that my y has to be r sine theta. So it's not sine theta, it's because I don't have r equal to 1. If I had r equal to 1, then the answer would be yes. So this is r sine theta. So if I know the r and the theta, I know the x and y of the point. So let us practice this a little bit, and then we will move backward. So let us practice this. So for example, okay. The question is, find the Cartesian coordinate of the following point. Find the Cartesian coordinate of the following point given in polar coordinate of the following points which are given in polar. So I'm going to give you a bunch of points in polar coordinate, and the question is we have to find them in Cartesian coordinate. So I'll start with the first point, 330 degrees. Now here, this is in polar. I want them in Cartesian. So I will draw the picture to show you exactly what I am after. This is in polar. It means it's 30 here. This is my angle, which is 30. And from here to here, it's 3. What I want to find is this one and that one. That's really what I want to find. So I want the Cartesian. So this point so far in polar, that's 330 polar. So I'm writing here polar to tell you that's in polar coordinate. Now I want to find them in Cartesian.
Calculator. It's very annoying that.
Okay, sorry about that. So now what is my x and what is my y? So we usually memorize those formulas because they are very useful. So what is my x? My x is r cosine of 30. So I am in degrees. My r here is 3. Cosine of 30. Now, cosine of 30 is, if we go back to our unit circle, it's one of those special angles that we should know their cosine. So let's remember in the unit circle here, the unit circle, if this is 30, this is square root of 3 over 2 and 1/2. It means the sine, the cosine of 30 is the square root of 3 over 2. So this will give me, that's it. And the y is the r sine of 30. It means 3. The sine of 30 is 1/2, which gives me 3 over 2. It means in my picture here, this coordinate here is 3 square root of 3 over 2. And this coordinate here is 3 over 2. That's really what, I mean, we've seen, of course, something very similar to it, but now we're giving it a different name. So in Cartesian, that's 3 square root of 3 over 2, and this is 3/2. And this is the Cartesian coordinate. So every point now have 2 coordinates, either the x and y or the r and theta. Okay, we will do another problem. And when you get the answers, they should make sense. So at least I know here that the x and y has to be positive because my point is right in the first quadrant. So if you get something negative, something weird, you should connect that. Let's do another one. Okay. So suppose now I have the following point. 4 and let's see, 130. I'm just making up number. All right. So now I need to find the x and y coordinate. So first, let's see. So this is in polar. Means I have 130. So that's 90. 130 would put me somewhere here. And I am from here to here. I have 4 units. That's the point. And sometimes it's not very clear, so that's, sorry. And this is my x and y axis. And this is my 130, okay? And this is 4. And the question is, we need to find the x and we need to find the y. So already I know something fairly simple, and this is the 130 degrees. I know that the x has to be negative and the y has to be positive. At least we know that. So what is the x, y coordinate? So x is r cosine 130. It means 4 cosine 130. And we know that the cosine has to be negative because we are in the second quadrant. And the y is r sine 130. It means 4 sine 130. And now we have to plug in into our calculator and figure out this answer. Anybody figure them out faster than I do? I do. How much is the x? Thanks, Travis. So it's minus 2.57. We expect negative answer. Anything but negative will be wrong because when we drew the picture, we know the x coordinate has to be negative. So this here is minus 2.57. And how much did you guys get for the y? 3.06. It means this one here, that's the 3.06. And now I have a point in both coordinate system. So I know it's 4, 130 polar, and in Cartesian it is minus 2.57 and 3.06. That's in Cartesian. Okay, so that's really the idea. Now I'm going to give you a point. Here you just apply the formula, so there is really nothing hard to it. But I'm going to ask you a very, very simple question. Suppose I take this point here. So this from here to here, 5. I want you to give me Cartesian polar? Without any formula, quickly, because that's a very simple question. What are the coordinates in Cartesian? What are the coordinates in polar? I want answers on chat. 0, 5, which one is this? Right next to it, polar or Cartesian, so I know. Cartesian 0, 5. 0, 5. That's Cartesian. Now I want them in polar. Five. That's how far? 90. Or 5 pi over 2. Absolutely correct. So those both are in polar. Okay. Now, if I know the polar are theta, I know x and y. We just have to use the simple formula. The second question is the following. If I know the x and the y, I know the Cartesian coordinate. So I know this and I know that. How can I find the r and how can I find the theta? Okay, so part 2 is, suppose we know, part 2 is conversion from Cartesian to polar. So let me explain what do I mean by that. It means, let us say, in this case, we know xy, the Cartesian. The question is how to find r and theta. That's what we know, how to find r theta. Okay, so I draw the picture and whatever I'm, okay. So this is my picture here. And this is my point. I know the x right there, and I know the y. And my question is how to find the r and how to find the theta. Okay, I start with the easiest one, and I'm having already some answers. How can I find the r? I know the x, and I know the y. Now, everything I will show you is on the first quadrant, but everything we say about the first quadrant is going to work everywhere. So if I know the x and y, how can I find r? Okay, if I use, this is a right triangle. If I use Pythagorean, r squared is x squared plus y squared. So if I know x and y, I can find r immediately. So that's the first rule. So r squared is x squared plus y squared. So this will give me that r, you don't have to memorize that, is the square root. I found my r. Now theta. How do you think I'm going to find theta? Okay, theta, you can, so if this is theta, I can use the tangent. So the second part is tangent theta, because I have the y and I have the x, it's going to be y over x. Okay, now, this will give me the tangent. To find theta is going to be a little bit problematic from this. I'm going to give you the rule and I explain where my rules are coming from in the example. So this will give me that theta equal, and I explain why I am writing that. It's going to be the arctangent y over x if theta is in quadrant 1 and quadrant 4. And I will explain that. I will explain it. But now I have to write it. And it will be pi plus, if I'm working in radian, arc tangent y over x if theta is in quadrant 2 or quadrant 3. And I will explain why I have to add pi in a second. Pi, or in degrees, you add 180 degrees. So you add 180 if you are in degrees. So in degrees, theta will be 180 if you are working in degrees plus the arctangent. So you can write this for now, and then I'm going to explain why I had to add 180. I did not only took the arctangent, and this will be clear in my example. So let's do examples. Okay. So the first example is, I'm going to give you the point in in Cartesian, and you have to find in polar. So find the polar coordinate of the following point given in Cartesian. Given in Cartesian. Okay. Now, let's see how we're going to do that. So the first point is 2, 3. In this scenario, 2, 3 is given in Cartesian. I want to find them in polar. So I draw the point, and it's absolutely crucial. If you guys are writing, absolutely crucial to draw the point first. So that's Cartesian. It means this is my 2, and this is my 3 right here, because those are in Cartesian. So this is my 2, and this is my 3. So that's really what I'm after. So this is the point right here. I want to find the polar. It means I need to find r, which is from here to here, and I need to find the theta. Okay, that's really what I need to find. So if we understand it, actually, we don't have to memorize any of this stuff. We just have to look at the picture. Okay? So let us find r. Okay, we're using actually Pythagorean theorem. We say that r squared is equal to x squared plus 3 squared, which is 4 plus 9 is equal to 13. It means my r is the square root of 13. So this will give me this piece right there, the square root of 13. Now I need theta. Theta is always the angle between the positive x-axis and the point P. So to find theta, I say, okay, this is theta. From here to here, it's 3. That's really what I am using. And this is 2. So we say tangent theta is 3 over 2. So theta is the arctangent. It's the angle. That's what the arctangent is. It's the angle whose tangent is 3/2. Now, I don't know how much this is. And since our calculator now is in degrees, so I'm going to stay in degrees. So I'm going to look for tangent inverse of 3/2. And it's giving me 56.3. 0.31 degrees. Now I expected, I am in the first quadrant, I expect my angle to be between 0 and 90. So I know exactly what my angle is going to be. So the polar coordinates are going to be, so the polar would be right there. Square root of 13, that's the r, and the theta is the 56.31. So these are the polar coordinates, and I am working right now in degrees. All right, example number 2. And this one you have to listen carefully. But this one, the first example is easy. I'm working in the first quadrant. Things are very simple. Now the second example is the following. I'm going to take the point -2, 3. This is in Cartesian. And I need to find the polar coordinate. Step number 1, always, you have to draw the graph. -2, it means this is -2, and this is 3. So this is the point. That's my point right there. I need to find the r, and I need to find theta. Remember, the theta is the angle between the positive x-axis and the point OP. So what is R? R is always easy. R square, it's 2 square plus 3 square. So the R is always simple to get. Square root of 30. Okay. Now theta. Now by drawing the picture, I know that theta has to be positive, and I know that theta is between 90 and 180 degrees. So I know that theta is in the second quadrant. Now, how can I find theta? Anybody has any idea?
When I put -2 squared plus 3 squared in the calculator, I got 5.
Because you did not put a parenthesis correctly. You see what I mean? You must have put it like this. If you put it like that, the calculator understands -4. Because it only squared the 2. You have to put the whole quantity -2 square. Did I answer your question?
Yeah, I did. Sorry.
Yeah, no, that's fine. Okay. All right. How should you want me to find theta? Okay. Suppose I'm going to use the following. Suppose I say, okay, tangent theta. I don't know. How do you want me to find theta? Can anybody pitch in a little bit? That's the picture in front of you. I want theta.
Wouldn't you take the inverse tangent of 3 over -2?
Okay, I'm going to try that. I'm going to tell you what the problem is. And that's what I want. So tangent theta is the tangent inverse of 3. That's the y over x. Very good. So what's going to be theta? And I'm not going to write it theta because it's going to be problematic. Suppose I take the tangent inverse of -3/2. All right? If I plug it into my calculator, what am I going to get?
You're going to get -56.
Right, I'm going to get -56. Point whatever we get, all right? Point, how much? 0.31. But is my angle here -56?
No, you have to add on 180 degrees.
Right, I have to add on 180 because the problem is the tangent inverse, the calculator gives you the angle between -pi over or -90 and 90, whose tangent is -3/2. So what the calculator is giving you, that's the calculator will give me that angle. That's the one the calculator give. This is the one that your calculator give, which is the -56.31. So the calculator is giving you that, but I want theta. It means this angle here is 56.31. So what I need, that's really my problem is, that's why I have to add 180. So this tells me that, so now I'm gonna scratch this. I'm not gonna put theta. So the calculator gives me tangent inverse of -3/2 is -56.31. That's the one the calculator is giving me. So my theta, I have to add the 180 to get my theta. That's why I gave you the rule at the beginning. And this will give me 123.6. So it's crucial for those problems, that you draw the picture. You know where your theta is. The calculator will give you, it will not give you that angle, calculator give you that. So which is the symmetric. I mean, this should be a straight line. That's the -56. So what you have, it means the 56 is here. So basically you're taking 180 minus the 56, or you can add, that's 180 minus the 56, which give you that. Okay, so that's why I gave you this rule at the beginning, because the arctangent only give you one angle, the one between -pi/2 and pi/2, and we have to compensate for that. Okay. All right, I definitely stop right there. You guys, I think the quiz should be out. Get going, and I wish you a good spring break. All right, start your quiz.